Hey guys, this is Mr. Gran, 13.1 right triangle trig. In this video, we will be solving word trig problems. All right, so some of our steps for doing word problems. We want to start out by, in the problem, highlighting the two sides and the angle, where they are in the word problem. That's going to help us figure out where those numbers go when we set up our drawing, right? So there's always, you're either given two sides and finding an angle, or you're given one side and the angle and finding the other side. All right, then we want to draw the triangle and place the two numbers and the x, right? Two numbers that were given and then the x representing the thing that we're trying to find. Then we'll label our sides, opposite, adjacent, hypotenuse. We'll use that to determine whether we're doing sine, cosine, or tangent. And then we'll set up our trig ratio and solve. All right, so first example, we've got a 12-foot ladder leaned up against a wall. The base of the ladder is 5 feet from the wall, and we want to know what is the angle formed by the ladder and the ground. So when I start this, I'm going to make my drawing. So here is my ladder. It's leaned up against a wall. The ladder, that forms a right triangle. The ladder is 12 feet long, and the base of the ladder is 5 feet from the wall. And we want to know the angle that's formed by the ladder and the ground, which I'll put an X in that bottom corner. All right, so now what are my sides? 12 is the hypotenuse. The opposite side is the wall, and the adjacent side is 5. So in this case, I'm not using the opposite side, so I'm using the trig ratio that uses adjacent and hypotenuse, which is cosine. So that is the ka from SOHCAHTOA. All right, so we'll set this up. Cosine of our missing angle x is equal to the adjacent 5 over the hypotenuse 12. And in order to solve this, we'll use inverse cosine. So x is going to equal inverse cosine of 5 over 12. And now we just got to plug it into the calculator. Second cosine, 5 divided by 12. And that gives us 65.38. Oops. All right, if you want to pause and try this one, and then unpause when you're ready to see me do it. All right, so we're flying a kite, and it has a 100-foot string. The angle formed by the string and the ground is 41 degrees, and we want to know how high is the kite. So I got my kid over here. He's holding a kite at the end of the string. That kite string is 100 feet long. The string and the ground, that angle is right here, so that is 41 degrees. And we want to know how high is the kite. So we'll put our X at the part of the triangle that represents the height. All right, 100 is my hypotenuse, X is my opposite, and my adjacent is the ground. I'm not using the adjacent in this case. The trig ratio that uses O and H is sine. So sine of 41, I like to put it over 1 in this case when we're cross multiplying, is x over 100, opposite over hypotenuse. So now I can cross multiply. And on one side I have x times 1. On the other side I have 100 times sine of 41. So we'll plug that into the calculator. 100 sine 41 and 65.61. That is how high in the air that kite is. All right, one last one for the video. If you want to try this on your own, I would say just make sure you read it carefully. All right, so it says a guide wire supports a telephone pole. The wire attaches to the pole 25 feet in the air. The wire connects to the ground 12 feet from the base of the pole. What is the angle formed by the wire and the pole? All right, so if I make myself a telephone pole here, so there's my telephone pole. It's like that. It's got some cables running to it, kind of off to the side. And there's a guide wire that connects to the ground, kind of keeps it from tipping over. That forms our right triangle. The wire connects to the telephone pole 25 feet in the air, and the wire connects to the ground 12 feet from the base, so that's our horizontal. And we want to know the angle formed by the wire and the pole. So the wire is the hypotenuse, the pole is the vertical, so our x in this case is going to go in the top of the triangle. All right, so now setting our opposite, adjacent, and hypotenuse, there's our hypotenuse. Because x is in the top, now the opposite is on the bottom, and 25 is our adjacent. All right, so I'm not using the hypotenuse. Ka is what we are going to use, adjacent and not ka, toa. Opposite and adjacent is toa. So that's going to be tangent of x is equal to the opposite 12 over the adjacent 25. And that means that x is the inverse tangent of 12 over 25. So if I plug that in, second tangent 12 divided by 25, and that gives us 25.64 for our angle.